Hello, today we're continuing our discussion about operations with complex numbers. So in our last round of notes, we learned about what an imaginary number is, we learned about what a complex number is, and we learned some of the basic operations like addition, subtraction, and multiplication. Today what we're going to do is we're going to expand that. We're going to talk about the powers of I, so when we have I times I times I times I, etc. We're also going to talk about division and what we do with division. So first off, I want to talk about the powers of I. So I want to look at if we have it. So we learned about I by itself. We know that I equals the square root of -1. We know that I squared, what I squared is, and we're going to continue kind of see if we can find a pattern. So the first one's I squared. We learned that was -1 the other day. So I need to figure out what I cubed is. What we're going to do is we're going to kind of break that apart. I know I can break I cubed into I squared times I. All right, because if technically this has an exponent of 1 there, 2 plus 1 gives me that 3 exponent. If I'm looking at that, I know that I squared, well, I squared is -1. -1 times I is just negative I. Now we're looking at I to the 4th power. I can break that into I squared times I squared. Well, I know I squared is -1, so I've got -1 times -1, which gives me +1. I to the 5th. I can break that into I squared times I squared times I. I know that I squared times I squared, that would give me that 1. 1 times I, which just gives me positive I. I to the 6th, that would be I squared times I squared times I squared. Those are all -1. -1 times -1 times -1 would give me -1. You notice we're repeating that pattern now because I squared was -1 and I to the 6th is -1. So that means I to the 7th is going to be the next pattern, which would be negative I. I to the 8th would be 1, I to the 9th would be I, and so on and so forth. So here's our repeating pattern. Our repeating pattern is starts with -1, then it'll go to negative I, then it'll go to 1, then it'll go to I, and then it will repeat that pattern. All right, so I want to talk about another type of pattern that we could see. All right, another thing that we notice is when we do these, I was talking about -1, so -1 times -1 or -1 times -1 times -1. We have patterns when it comes to -1 being raised to some power. So if we have -1 raised to an even number like 2, 4, 6, 8, all right, that will result in 1. If I have -1 raised to an odd number like 1, 3, 5, 7, 9, that will result in -1. And that's going to be a key concept for us here. Okay, so we're just going to do an example like this. I to the 2,187. Now, we would not want to sit here and break it apart into all those i's that we did for those first couple powers. That would take us way too long. All right, but if we break it up to sets of even numbers, that can kind of help us out. So what I want to do is 2,187 an even number? No, it's an odd number. What's the closest even number underneath it? The closest even number underneath it was 2,186 times I. So if I did that problem there, I kind of break it apart, I would still get 2,187 when I actually do that multiplication. Now I'm going to break that 2,187 and divide it by 2, so because I know what I squared is. That's something I know. It's an easy power to remember. If I do that, I squared, if I take 2,187 divided by 2, I get 1,093. Let's look. We know I squared. That is one that we have got down. It's -1. Now we can remember our -1 facts. If you look at that, 1,093, that's an odd. So we know no matter what, it's always going to be -1. So actually that is just -1 times I, which will result in -I. So I know 2,187, I to that power, is going to give me -I. That's our second number in that pattern there. So you can figure out whatever number I throw at you by breaking it down to I squared, because we know what I squared is. It's common to us. All right, what we're going to do next is rational denominator. This is the last operation we've learned, which is division. When we do this, it's very similar to what we did with square roots or radicals. We want to multiply by that radical or the conjugate to help us out. So my first problem here is 3 plus 2i. So what I would do is I want to multiply both the top and the bottom by I. And we do that by a factor of 1, multiplying both the top and the bottom. So 3 times I, that would result in 3i. 2i times I would give me 2i squared. We know better. What is I squared? Well, I squared is -1. So that would result in -2 on the bottom. And that would be my final solution. So again, just like the radicals, we don't want them in the denominator, right? We want a nice real number in that denominator. We don't care if it's in the numerator, that's fine. We want to get rid of it in the denominator. Number 2 is going to take us a little bit more work because unlike number 1, number 2 has some operations in the bottom. So we've got 5i divided by 3 minus I. So what we do is we have to multiply by 3 minus 5i's conjugate. The conjugate here would be 3 plus I. So on top, I would be doing 5i times 3 plus I over, bottom I would do 3 minus I times 3 plus I. So it's going to take a little bit more distributing than the last one. So I've got 5i times 3. That would give me 15i. And then 5i times I, which would give me 5i squared. On the bottom, I've got 3 times 3, which would give me 9. 3 plus I would give me 3i. Negative I times 3 would give me negative 3i. And negative I times negative I would give me negative I squared. So from here, we just need to start simplifying. So look at the top. Is there anything we can simplify in the top? The only thing I see that we can simplify in the top is this I squared. Okay, we know that I squared is -1. So I could rewrite that as -5 plus 15i. Because remember, we want that real number to be out in front. In the bottom here, we've got 9 plus 3i minus 3i. So those 3i's will cancel out. So I've got 9 minus, and we know that I squared is -1. Well, 9 minus -1 is just a positive 10. Okay. Now that's a good answer here, but remember, when we're working with imaginary or complex numbers, we want to write it in that complex number form where we have our real number plus our imaginary number. So we're going to kind of break this apart here, and here's how I break it apart. I take the first thing here as my first fraction. So I've got -5 over 10 plus, and I take my other part there as my other fraction. So 15i over 10. And I'm here, I'm going to simplify both of those individually. So -5 over 10 would give me -1/2 plus 15 over 10 would give me 3/2 I. And that would be my final solution because we want to write it in that complex form. All right, so the main or key concept here was the conjugate. So don't forget about that word conjugate. Another key concept here was making sure our answer is always written as a plus bi when we have imaginary or complex numbers.